Which is the best option for investing your money? Option 1, a compound interest account that compounds yearly at 8% per annum, or a simple interest account with a flat rate of 12% per annum. Well, clearly here, if you're going to invest for 1 year, the first option would go up by 8%, but the second option would go up by 12%. So the simple interest, clearly the best option over 1 year. Over 2 years, well, the simple interest would go up 24%, but the compound interest, due to its compounding nature, wouldn't go up by 16%, it would go up by a little bit more. So over time, the return in a compound interest account gets better and better and better due to the interest on interest that we earn. However, the simple interest account doesn't improve. You're always going to get paid the same dollar amount of interest each year. So it doesn't matter what the compound interest account offers, over a long enough term, it will be the better option than a simple interest account. So these questions are all about when is the compound interest option the better option. Okay, so we're going to use Desmos to go through the same method that you'd use under test conditions to solve a problem such as this. Okay, so we'll look at the 8% compounding yearly. You're not expected to graph that from the function, which means you're going to have to make calculations of after 1 year, what's the value in the account, after 2 years, what is the value in the account, and then put a line of best fit through your data points. Okay, so to do that, you need to come up with a table of values. So I'm going to do that in Desmos. I've got x1, which is the number of years, which is plotted along the x-axis. And here I've got the amount in the account. So we see initially that we're starting with $10,000. And here I've got a calculation that will calculate the amount in the account. It's $10,000 plus 0.08, 8% per annum, compounding yearly, and x1 is my number of years. So then after 1 year, I see the amount in the account is $10,800. After 2 years, 3 years, now let's plot these on the graph, and I see it's increasing. So the rate of increase looks fairly linear at the moment. But if I keep on going and start populating with some more figures, we see that, in fact, this is clearly not linear, and that's because the extra dollars added into the account each year is getting bigger because of that interest on interest effect that we see in compound interest. Okay, so 14 years, 15 years, and it's going off the chart. Okay, so in a test scenario, maybe you'd have to graph it over 8 years. I wouldn't be expecting it over 15 or 16 years. But it's pretty quickly to do that on your calculator efficiently. Okay, so we see here that to get an accurate graph here, you need to calculate values and then put your line of best fit in. We could do exactly the same thing with our simple interest account, but we know that the simple interest account would be a straight line because the dollar increase will be the same each year. So if you did the same table here in a test, you'd be wasting a lot of time because it's going up at a constant rate. And to sketch a straight line, you need 2 points. Okay, so to demonstrate that, let's put in a new table. So x2 and y2. Okay, so after 0 years. So to calculate the amount in the account for our simple interest account, the formula is our principal, our $10,000, plus the interest we earn, which is $10,000 times the rate, which was 12%, so as a decimal 0.12, times the number of years, which is our x2. Okay, so that better change the colour, so it's not green. Let's go purple. Okay, so there's our simple interest. So then after 1 year, 2, 3, 4. So making all of those calculations would be a bit ridiculous. Okay, so all I'd expect you to do in a test is perhaps go over 15 years, and then you can add a straight line from the start to the finish. Okay? But I can't really add a straight line or a line of best fit easily here, so I'm going to include the formulas. So for the simple interest account, the amount in my account is $10,000 plus 10,000 times 0.12 times X. Okay, so there's the amount in the account in the simple interest account. Okay, let's just trim it a little bit. Okay, so now for the compound interest formula, y equals the principal times 1 plus I, the 8%, compounding yearly. Okay, so this curve here that I'm seeing is called an exponential curve, and we'll talk more about that in a couple of weeks and a lot more about it in your extended maths. But we see here that the curves are intersecting, and they're intersecting at the point 10.8 years. They've both got $22,959.48 in the account. Okay, so if you're going to make an investment for longer than 10.8 years, the compound interest is a better option. However, if you're investing for less than that, the simple interest is a better option. So in a test scenario, you'd be expected to find the intersection point of your lines of best fit and then just read where that point is on your graph.